Oh, hi there, everyone. Thank you for showing up for your learning. I really appreciate you making the commitment to this standing appointment that we keep with each other. That every day at 1 o'clock we decide collectively that we'll spend 75 minutes of your day together to talk about math. I wonder what percentage of your day is that? I'll leave that hanging as a kind of challenge problem. But really, what you would do is divide 75 by the number of minutes in the day, or 1.25 divided by 24. Anyone? Yeah, that's another way you could do it. So, anyway, this is a joke, and it's not a joke. All right? Fractions are better than decimals. And you will find that they are indeed, you're always welcome. Fractions are indeed better than decimals. I'm teaching my grade 11s starting today some new things where you have to use your fraction skills. You're multiplying, adding, and subtracting fractions. Converting to a decimal is not always available. So we want to develop these skills for the future. But also, I promise you, when your fraction skills are really high level, it becomes more convenient than decimals. So let's take a look. I'm not going to be taking points off if you give me a perfect decimal answer, but oftentimes a fraction answer is better. You Sorry, go ahead. Why is my face there? Up here? Oh, because I'm taking a video. And that way people at home can see what a bad hair day I'm having. And they don't miss out on the pleasure that you all enjoy of seeing my bad hair day. This is my way of being equitable to the people who are at home. All right, so let's take a look at this handout here, which is going to practice going between these two forms. You want to use both decimals and fractions. They're both useful for different reasons. If I see a weird fraction and I want to compare it to other weird fractions, I'll convert to decimals to find out which one's bigger, which one's smaller, these types of things. So let's go. So there's 4 different forms that we can have these numbers written in. And when I say these numbers, I'm referring to the numbers between the numbers. Between 0 and 1 are how many numbers? Yeah, quite a lot. Would you say there's 10 numbers between 0 and 1? 100 numbers between 0 and 1? Yeah. Yesterday, Cohen said, let's just keep adding decimal places and we'll have an infinite number of numbers between 0 and 1, right? Yeah, so we have a lot of different ways we can represent these things. So let's see how we convert them. Decimals to percents to improper fractions and mixed numbers. All right. First of all, how do I take that first one, 0.25, and convert it to a percent? Yeah. So when you're doing these to percent, you just multiply by 100 and then add the percent sign. What's another way of saying multiply by 100 in our number system? Move it 2 decimal places. So I'm going to move that 2 decimal places over. That's 25, and then I add the percent sign. There we go. Multiply 0.25 by 100, you'll get 25. It's that many percent. So if I had 1, how do I write 1 as a percent? Let's say I have this. I'm going to erase this. But if I have 1 as a decimal, how many percent is 1? Oh, I just multiply by 100. That's 100%. So 1 is 100%. Just putting that in as a benchmark for your thinking. Any percent that's less than 1 means it's less than 100. It's less than 1. Now, how would I write this as a fraction? Well, if you know that this to be 1 over 4, that's not the mixed number, it's just the fully reduced one, then that's great. How did you know that 0.25 was 1 over 4?
Because if you divide it in 4 groups, 25% is 1 of them.
Cool. So 25% divides 100% into 4 even pieces, right? Yeah, you could say, oh, I only got 25% on the quiz. Oh, what was your mark? Well, there was 4 questions on it. I got one of them right. Yeah. The way I think about it is, if I put this dollar sign here, just about everyone will tell me that's a quarter, right? 25 cents? 4 quarters equals 100% of $1, right? $1, 100% of a dollar, it's 4 quarters. And cent has the word cent in it. So that's a big clue that it's out of 100. One way I can write this as a fraction that's not reduced is just put that 25 over 100. And then I could write this in another way. I'm doing this because this is an easy one, but we're going to see ones that aren't so easy pretty soon. So 25 over 100, I can write that as 25 times 1 over 25 times 4. And then this 25 cancels that 25, and I'm left with the answer 1/4. So that's a method to do that, even though I can just look at it and know. And looking at it and know is okay. If you can look at it and know what it is, that's great. But you'll want to have a method for something like 36%. First of all, what's 36% as a decimal? That's right. We're just going to have 0.36. Notice it's a little bit bigger than 25, and this is a little bit bigger than 25%. Cool. Now, how would I do that as a fraction? Think about it from this one here. Or this one here would work fine too. Over here, this was 25 over 100. What place is that in our number system? Here's the ones. There's 0 ones. Here's the tenths. There's 2 tenths. Here's the hundredths. So I put it over 100. I can do the same thing here, right? Or with a fraction, with a percent, 36% just means 36 over 100. And let's zoom in on that and see if we can reduce 36 over 100. At that point, maybe I do some rough work actually. So let's go ahead and do some rough work over here. So you might put in some rough work and say 36. I wonder what the factors of 36 are. Hey, Mr. Jennings, why don't we use a factor tree? Good, I'm glad you asked. Is that number divisible by 2? Yes. What do I get? Maybe I'm not sure, so I do it longhand because my calculator is all the way across the room and I'm lazy. So 2 goes into 3 one time, leaves 1 remainder. 2 goes into 16 8 times. There we go. 18. So this is leaves me 18. Is that number divisible by 2? Yes. And what do I get? 9. Okay, 9. And 9 is just 3 times 3. 9 is not divisible by 2, so the next thing I'll check is divisibility by 3, and there it is. I just check bigger and bigger primes. So I can write 36 is equal to 2 squared, because there's 2 of them, multiplied by 3 squared. Now let's try the same thing for the bottom of this fraction, 100. Okay, 100. What are its factors? Sure. And when I divide it by 10, what do I get? 10. Now what are the factors of 10? 2 and 5. Good. So I have 2 and 5 twice. So there, 100 is 2 squared times 5 squared. So I can write that way. I can say that this is equal to 2 squared times 3 squared divided by 2 squared times 5 squared. Okay. Now, is there anything in there that can cancel? I got 2 squared divided by 2 squared. What's that? Just 1. Yeah. This is 4 divided by 4, multiplied by 9 on the top, multiplied by 25 on the bottom. It's just 9 over 25. And we'll find that's the best simplification we could have for the fraction 36 over 100. All I do is I write it as prime factors, and I cancel out anything that's on top and bottom both. Okay. Now let's take a look at an improper fraction. So here we have 5 over 2. First of all, let's guess what we think the decimal would be. If we did 5 divided by 2, what do you guess we'd have? You have 5 donuts, and you want to share them evenly with your friend. How many donuts should everyone have? Yeah, 2.5. Or another way to write that is 2.5, right? Yeah. So this is 2.5. 2.5 is a decimal. And how can we do that? Well, we can get out a calculator right after I pause this video and go answer the phone. All right, let's keep going. So now how can we convert that? Well, we can get out a calculator and just do it. 5 divided by 2. Move my useless face up here. There. I'll peer at you from up there. Equals 2.5. There it is. So you just do the division, and that's how you can convert to a decimal. Easy. But it's good to guess first because it's faster. And you'll often just have a very good idea of about where that number sits on the number line. And you're going to practice that with an activity today. How many percent is 2.5? If I want to answer that question as a percentage, yeah? Good. All you do is multiply by 100 or move the decimal place twice. You don't invent new ways to do it. You don't say, well, maybe it's 25. No, it's not. It's 250%. If something gets 2.5 times bigger, it's 250% bigger. Well, it's 250% of what it was before. It grew by 150% actually. So there you go. All right, now let's talk a little bit about how we convert there. So what I do is I say, okay, I got 5 halves. And one thing that I can visualize are pizzas. So let's draw 5 halves of pizza. Here's one whole pizza cut into 1, 2 halves. Here's another whole pizza cut into 3, 4 halves. And I have one more half there. So I got 1, 2 full pizzas and 1 half. So there's my mixed number, 2.5. Go ahead and visualize your pizzas. Cohen?
I was calculating the points for the addition class.
Yeah. Ask me after. And so here, this is 2.5. And what you can do is say, okay, I'm going to look inside my 2 times tables for a number that's almost as big as 5, but not quite as big as 5. Like, what's the biggest number I can multiply 2 to that's still smaller than 5? It happens to be 4. So that's going to be this number here, and that's going to give you the total number of wholes that you'll have. 2 times 2 is 4, so I have 2 wholes. And then 1 half left over, because 5 minus 4 is 1. So let's take a look at going the other way. If I start with a mixed number, like 3 3/4, how can I convert that to an improper fraction? I want some number over 4 here. What will I do?
Multiply 3 by 4.
Yeah. So I multiply 3 by 4, 3 times 4, and then what do I do with that 3 on top?
You add it.
Then I'm going to have plus 3. So this number multiplies that number down there, and then we're going to add it to that number. And we're going to have that all over 4. Doing Bedmus there, I have 3 times 4 is 12, plus 5, sorry, plus 3 is 15. 15 on top over 4. Now, let's go ahead and visualize pizzas. It's not that many pizzas here. I'm going to change my color so it's more clear. Here are 3 pizzas. 1, 2, 3 whole pizzas. So that's the 3. That's the whole number there. 3 whole pizzas. And let's cut them into quarters for fun. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 slices. Just count it, skip count it by 4s. And then I have 3 more slices there. Okay. 13, 14, and 15 slices. So visualize pizzas is a great way to make sure that your fractions are working out. Another really useful tool is to visualize an amount of hours. So if I said 3 3/4 hours, you would say, well, 3 hours, that's 180 minutes. 3/4 of an hour is 45 minutes. So I've got 225 minutes there. 225 over 60, you could then reduce that if you wanted to have it as a mixed fraction. Pizzas are better in this case. So what would this be as a percent or a decimal? Guess first, and then we'll check. 15 over 4. Liam.
375%.
375%. Good. And that's going to be as a decimal, 3.75. Fantastic. Oh, it's not percent there. It's just a number. So how did you do that, Liam?
I used my head.
Okay. Yeah. 15 divided by 4 is, oh, look at that. You were correct. So how is your head so good at this?
Well, I took like 3
Yeah.
and then put it first, and then I take
3/4?
3/4, which is 75.
Yeah. So here's the 3. That's this 3 here. And then 3/4 is 75 cents. You can put that there. Great. Yeah, that's perfect. So those are cases where when you just know, you know. But then you can check with your calculator. Divide 15 by 4, and if it's the same thing, then everything works out. What if I have a number like 1.125? What's that as a percentage?
112.5.
Yeah, this is 112.5%. Good. And there's going to be lots of times where we want to convert between decimals and percents. This is, it looks trivially easy, but you're going to get crazy numbers in your financial math if you forget to change that factor 100. It really changes stuff. So you really want to make sure you do that very easily. Now, how can I write that number as a fraction? 1.125. Upstairs, we said this was the hundredths place, so we can put it over 100. What do I need to put this number over in order to convert it to a fraction? What place is this? That's the thousandths. So then we will have 1125 over 1000. Do you think those two numbers share factors? Like, is that fully reduced or not? When the number on top and bottom shares a factor, we know we can simplify it and simplify the fraction. We want to start doing that as a habit. Before I convert that to a mixed number, as a mixed number, it'd be 125 over 1000, 1 and 125 over 1000, but I don't want to do that. I want to convert it to a reduced fraction first. Voila, there it is from the morning. But let's put it up here for those of you. This is a good one to go through. Let's change our color again and do some rough work on the side. And do a factor tree. 1, 1, 2, 5. First thing I check for is divisibility by 2. Is that number divisible by 2? No. So what's the next prime bigger than 2? 3. 3 is also prime. Is that number divisible by 3? How do you know if a number is divisible by 3? If I add the digits together, Mr. Jennings, and the result is divisible by 3, then the number I'm looking at is also divisible by 3. So add the digits together. What do we get? 9. Is 9 divisible by 3? Yeah. In fact, this number is divisible by 9. But let's just divide it by 3 and see what happens. If I take out a factor 3, what will I get? Can anyone do that in their head? No? Let's do it on a calculator then. You can absolutely do these on a calculator, but I would encourage you to start doing them as mental math for your practice. 1125 divided by 3 will give us 375. Is that number divisible by 3, 375? Yes. And this one divides a little easier by 3. We get 125. Because 3 goes into 3 once, and 3 goes into 75 25 times. That's how I would do that. Okay. So there. Now, 125, is that number divisible by 3? No. 1 plus 2 plus 5 is 8. 8 is not divisible by 3, so we're done taking out our factors 3. Let's check the next biggest prime. What is it? 5. Is this number divisible by 5?
Yes.
What do I get?
5.
25. That's right. Is 25 divisible by 5?
Yeah.
Yes. It's 5 twice. So there we go. That's a 1,125 written a new way. Let's write 1,000 a new way. Oh, 1,000 is just 10 times 10 times 10. And each 10 is 2 times 5. 3 times. So what this allows us to do is write this in a new way. I'm going to write this as 3 times itself twice, 3 squared, multiplied by 5 times itself 3 times, 5 to the 3, all divided by 2 times itself 3 times, that's 1,000, multiplied by 5 times itself 3 times. Now, tell me, what can I cancel in there? The 5 to the 3 cancels top and bottom. So, boom, boom. This is equal to, what is that equal to at the end of the day? After I've taken out the factor 125 top and 125 bottom, what am I left with? 3 squared on the top and 2 to the 3 on the bottom. 9 over 8. So 9 over 8 is the fully reduced improper fraction. Let's write that as a mixed number. What's that as a mixed number?
1
over 8.
Yeah, 1 and 1/8. This is one full pizza, that's 8 over 8, and then there's one left over, 1/8 remaining. Okay? And visualize your pizzas and you'll see it. Like actually see pizzas. Imagine opening the box. It's already been cut into 8 slices for you and your mouth starts to salivate. You open the second box and you're mildly disappointed to only find the 9th slice. There's 8 slices in one box, but someone has already eaten 7 slices of your 2 pizzas. So there's only 9/8 of pizza left. Originally there were 16/8, but now it's 9/8. Don't worry, you still have 9 slices of delicious pizza to enjoy with your Netflix. So now let's compare that to the decimal, 1.125. Let's check our work. Okay, I'm going to take 9 and divide it by 8. Ho, look at that. It's the same thing. So we just want to get very comfortable going back and forth with those types of things. All right, it's 1:45. So I thought I could do a few more examples, but I'm moving a little slower than I thought I might be. Let me show you this one, 35 over 16. What I want you to be able to do with that is say, okay, I'm going to guess first and then check. 35 over 16, I know that's a little bit bigger than 2 because I know 2 times 16 would be 32. So 32 over 16 is exactly 2. So 35 over 16 is 3/16 bigger than that. So I could write it over here as 2 and 3 over 16. And now I look at 3 over 16 and I say, wow, 3 over 16, that's got to be something like 0.2, maybe 0.2-ish. So maybe I guess that this is like 2.2. Put a question mark and then check it. Okay. Get out my calculator again. Divide 35 by 16 and find this 2.1875. Darn, I was pretty darn close. I was out by 0.0125. What's that, 1/80th? I was out by an 80th. Anyway, there we go. So it's actually 2.1875. And then I'll write that as a percent. 218.75%. So it's basically 219% or 220%. My guess was good enough for rock and roll. There we go. My guess would also be good enough if I had to graph that semi-accurately. It's enough to put it on the graph if you had an answer 35 over 16 to know it's about 2 1/5. Yeah. So there you go. 3 and 13 over 15. Wow. I would guess like 3 point, it's got to be like 8 something. Like let's say 8.3. I don't know. Let's guess. 13. So to check this one, 13 divided by 15. I would do this and I say, oh, it's 8.6. Okay, so I was pretty close. And then I add my 3, right? If I want to convert this to a mixed number, well, what I would do is imagine 3 full pizzas. That's going to be 15 slices 3 times. So that's going to be 3 times 15 plus the extra slices, 13 slices, all still divided by 15. And that will be equal to 45 plus 13. That's 58 over 15. And then I can check my work. 58 divided by 15 is equal to 3.86 repeating. So that's the same thing I was getting over here. 3.86 repeating. 6 is on forever. Okay. This was my guess. Pretty close. There we go. So in the handout that you have, this one here, you can practice turning fractions into decimals and percents, but then look over here and see the handwritten note that I gave you on how you convert fractions to decimals. Yeah. I want you to add this step of guess first and then check with a calculator. Just check with a calculator shows me that your fingers are slender enough to push the buttons accurately. But if you guess first and then check your guess with a calculator, you're building your mental math skills. You're building your intuition and number sense. And that's why I want you to guess, calculate, check. Guess, calculate, check with each one of these. Go.
It's yours.
And any questions, hit me up by email or come visit me in class. Bye for now, everyone.